Area of rectangles. Area of a closed region. In the last unit, a quadrilateral was defined as a closed figure composed of 4 segments joined at their endpoints. A rectangle was defined as a quadrilateral with 4 right angles. Be careful to recognize that when asked to find the area of a rectangle, you are being asked to find the area of a rectangular region, the rectangle itself, and all points in its interior. So here we have a rectangle. The rectangle is the boundary. This is the interior of the rectangle. The rectangular region is the boundary and the interior. By agreement, when asked to find the area of a triangle, a trapezoid, a parallelogram, or for that matter, any closed figure, you are looking to find the area of the boundary and the points inside the boundary. The parallelogram is the boundary. This is the interior of the parallelogram. The area of the parallelogram is the area of the boundary and the interior. Here are some foundational postulates. The area, A, of a square is the square of the length of a side, S. So area equals side squared. To start, the dimensions of a unit square is 1 by 1. Its area is equal to 1 square unit. The dimensions of the square to the right is 4 by 4. Its area is equal to the number of unit squares that are included in the grid it surrounds. So the area of square ABCD equals 4 squared, which is 16 square units. So here we see a unit square. See 1, 2, 3, 4 going down like that. Here's another postulate. If 2 closed figures are congruent, then their areas are equal. Area addition postulate. The area of a closed figure is the sum of the areas of any dissection of non-overlapping contiguous parts. So the area of this shape here, ABCD, equals the area here in area 1 plus the area here, area 2. Here's a theorem. The area of a rectangle is the product of its base B and its height h. A equals BH. Given a rectangle with base B and height h, prove its area equals BH. Alright, so the area of the big square here is B plus H squared. So we've taken that rectangle that's B and H, and we've created a square by turning this rectangle on its side here and then creating these little squares here. So the area of the big square is B plus H times B plus H. So B plus H squared equals B squared plus 2BH plus H squared. And then we have BH here. We know that BH equals A, so we replace that with A. Then we have some substitution, B squared plus 2A plus H squared. And therefore, 2A equals 2BH, so A equals BH. Area of a rectangle. In general, the area of a rectangle is equal to its base multiplied by its height. This can also be referred to as length times width. So area equals length times width, which also equals base times height. Sometimes the dimensions will not be given, so you will need to calculate them before you can determine the area. Since a rectangle is a quadrilateral with 4 right angles, a diagonal will dissect the region into 2 right triangles. Therefore, the Pythagorean theorem will be helpful on occasion. Another helpful formula is the perimeter formula for a rectangle. P equals 2 times length plus 2 times width. The area addition postulate. Given ABCD and CPQR are squares. The area of the shaded blue area is 72 square units, and the area of the removed square is given by x squared. Question: what is the perimeter of the shaded figure APRQPB? Alright, so we have the area of the square, the large square, 3x squared, equals this portion, x squared, plus 72, which is the area of the blue region. Then we solve for x. We get that x could equal plus or minus 3, but since we're dealing with areas, we only want the positive result, so x equals 3. The perimeter equals 12x. When you plug in x, you get 36 units. The diagonal of a rectangle is 15 feet, and its length is 3 feet more than its width. What is the perimeter and the area of the rectangle? Alright, so first we're going to use the Pythagorean theorem to find x. Here we have a right triangle where the hypotenuse is 15, this side is x plus 3, and this side is x. So we plug that in to Pythagorean theorem, solve for x. We get that x is negative 12 or 9. So we're going to use the positive result since we're dealing with areas and lengths. So the width is 9, x, here, and the length is x plus 3, which is 12. The perimeter is 42, and the area of the rectangle is x times x plus 3, which is 9 times 12 when you plug in 9 for x, and that equals 108.